Hi, this is Don from WEST SYSTEM Epoxy. Today I want to talk about fastener bonding. In the world of boating, sealants or adhesive sealants is the primary method many people use to help keep moisture out of fastener holes. What most people don't realize or forget is that sealants have a lifespan. This is about 10 years, give or take, and the sealant's effectiveness can be reduced if it's not applied properly in the first place. This is why we recommend using WEST SYSTEM Epoxy in conjunction with sealants when installing fasteners. There's two primary reasons to use WEST SYSTEM Epoxy when installing fasteners. The first reason is it increases the fastener's holding strength, and second, WEST SYSTEM Epoxy is an effective moisture barrier. Moisture intrusion can cause major problems. Often with a core laminate, like on the deck of a boat, you don't realize that the sealant has failed until you have a soft deck and discover that you have rotted core. Even with foam core, moisture intrusion can cause delamination from freeze and thaw cycles. This little bit of moisture can lead to an expensive problem. In our winch installation video, we discussed using epoxy to prevent moisture intrusion for through bolts, but today we're going to discuss situations when you're not able to through bolt, like a motor mount or deck hardware into a blind hole. To demonstrate proper techniques to increase holding strength and create an effective moisture barrier, I'm going to use these lag screw that has an eyelet and mount it into these blocks using WEST SYSTEM Epoxy. The blocks that we have here are all cut from the same piece of mahogany. This is a good baseline to compare the performance of each of our different techniques to one another. Keep in mind that the different species of the wood and wood grain are going to affect the holding strength. So this is just a comparative test. We're going to be using our 105 epoxy resin and 206 flow hardener in all of our epoxy blocks with our fasteners here, which is 1 inch long. So each of the blocks are drilled 1 inch deep with a standard size pilot hole. Block number 1 will be our benchmark. It'll be dry wood with no epoxy and our fasteners screwed into the block. Block number 2 has been soaking in water for about a week. Moisture in the wood will decrease the holding power without it being rotted. Block number 3, the hole has been soaked with epoxy for about 5 minutes, then I added the fastener. Block number 4, we oversized the hole by 50% using a 3/8 inch diameter drill bit, drilling down 3/4 of an inch down, leaving a 1/4 of an inch pilot hole for our fastener before we filled the area with WEST SYSTEM 105 epoxy resin and 206 flow hardener, thickened with 404 high density filler to a non-sag consistency. Another good option you could use would be 406 colloidal silica as a filler for bedding in hardware, as it is also a higher density filler. Block number 5, I'm going to install a removable fastener. Since we're using the eyebolt in conjunction with nuts, I'm going to use a machine thread eyebolt. I'm going to coat the threads with wax so it releases from the cured epoxy. Then I'm going to add 2 nuts, one at the top and one at the bottom. The threads on the nuts will hold up better than the epoxy threads for repeated uses. Then we'll oversize the hole to accommodate our nuts. Then I'll fill the hole with epoxy and let it set and soak into the wood for about 5 minutes. Then I'll pull the excess out with a syringe and thicken it with 404 high density filler. I'll coat the threads generously with epoxy, then insert it into the hole. I'm going to leave the top nut proud of the surface so when we mount hardware, it bears down onto the nut surface. Now that we wrapped up installing our fasteners into our wood blocks, I'm going to set that aside and we'll let the epoxy cure for a minimum of 24 hours. Before we test it. And like I mentioned before, moisture can get trapped in a cord laminate in between the skins. So we have these little sections up here of like 3/4 inch balsa with 1/8 of an inch fiberglass skins on each side. And we're going to do the same test. We're going to bond in fasteners in different methods and see how that affects our testing. Block number 1, we have our pilot hole, and I'm going to install our eyebolt in here without any epoxy. Block number 2, we have our standard pilot hole. We're going to fill it with 105 206 so it's completely full, and then let it soak in for 5 minutes and top it off if we need to, and then I'll hand tighten in our fastener. Block number 3, I'm going to oversize the hole 50%, which is a 3/8 of an inch diameter drill bit. And I'm going to drill down 3/4 of an inch deep. Then I'll fill that with a 105-206 mixture and fill it completely and let it soak in for 5 minutes. Then remove the excess and backfill it with the 105-206 and 404 high density filler to a non-sag consistency. Again, you could use the 406 colloidal silica filler as an option. Block number 4, we're going to use a bent nail to remove some core between the fiberglass skins. So this opens up a cavity so that we can backfill with the epoxy. So we're going to fill the cavity with 105-206 thickened with 404 high density filler. Again, you could use 406 filler. And then I'm going to insert the fastener into the hole. So now that we have all our fasteners in our composite blocks, I'm going to set this aside and we'll wait till tomorrow to do the testing. So now that we waited a minimum of 24 hours, we're going to test our blocks. So what I have here is we have a fixture that is got a load cell mounted onto it. This is a 5,000 pound load cell and it's wired into this digital display here in pounds. So we're going to get an idea of the strength of each of our different techniques of our blocks to extract our fasteners. For block number 1, the fastener pulled out with a small amount of wood failure. For block number 2, the fastener easily pulled out of the wet block. For block number 3, the fastener pulled out of the block with complete wood failure. For block number 4, the fastener pulled out of the block with wood failure and thickened epoxy remaining on the fastener. For block number 5, the fastener pulled out of the block with a large amount of wood failure and the nuts can be removed from the fastener. For composite panel number 1, the fastener easily pulled out of the panel with minimal wood failure. For composite panel number 2, the fastener pulled out of the panel with balsa remaining on the fastener with minimal damage to the fiberglass laminate. For composite panel number 3, the fastener pulled from the panel, failing a large area of fiberglass laminate. For composite panel number 4, the fastener pulled out of the panel with a large area failing the fiberglass laminate. So this wraps up our testing of our blocks. As you can see, a small amount of WEST System Epoxy is going to greatly increase its holding strength and create an effective moisture barrier. One thing you just want to keep in mind is the material that you're using is going to affect its holding strength. I hope you found this video helpful, and thank you for watching.